Hi guys, this is Vibhan Sugar. Today I'm here to provide you a brief overview about the tool MemCloud that I have been working from last few months. So MemCloud is in short a distributed in-memory data store. Okay, so by using MemCloud, we can say we can turn our nearby devices into our personal RAM farm or something. A huge RAM we can have by connecting all the devices together. So more about it we'll see in the further slides, and also in this video I'll provide you a quick demo of the commands and all the features that are provided by MemCloud and how you can leverage the RAM that is provided by your PA devices connected over the same network, Wi-Fi network or LAN network. So we'll see in this video only. So this video might be a bit long, but stay with me. Uh, so MemCloud started from a very practical problem I kept running into. Like the modern systems, especially AI and the data heavy workloads, don't usually fail because of CPU. They fail because of memory. Because memory is very limited, so these heavy operations require a lot of memory to run on. So due to this memory shortage, they fail. So like it is very often to see yeah, one machine is crashing with OOM errors while another machine sitting right next to us on our table with gigabytes of unused RAM. So this is a very huge problem here. We are having multiple devices and one device is facing this memory shortage and another device is having a lot of unused RAM. So the real pain is like I faced this personally while running local AI model on my personal computer. So when I was trying to run Olama on my Mac device, so it ran out of memory due to which I was not able to run it on my device. So that thing struck my mind here. Why can't I use the RAM that is present in my Ubuntu device, such that this Mac can use the RAM from another laptop sitting beside me. So this thought, pushed me to build something that can, that can help me achieve this theoretical concept that I just thought into a practical one. So that's why I built MemCloud. So the why existing solutions don't work. So the swap memory is very slow. Like swap memory, as you know now, it is a portion of your disk memory only that you are using as a swap. So it is very slow, and disk is also very slow. And if we try to move everything to the cloud, so they will defeat the purpose of running things locally. So what I wanted was simple. So I used RAM, not disk. And since we are using RAM but on a peer device, so there might be a small latency between the operation, but that is very negligible as compared if we were using disk. So the idea is to borrow memory from our nearby devices, and the applications that are running, they will keep unchanged. Like we don't need to make any code changes or any kind of settings. We don't need to change anything. MemCloud is there, it will handle everything. Like you can just run any applications using MemCloud and it will just delegate that RAM portion to some other device sitting on the local network. So the core idea is MemCloud lets machines share unused RAM over the network and exposes it as a best of effort remote memory layer. If one machine is memory starved or deficient and another has spare RAM, MemCloud connects them. So this is the idea. So the example we can have is while running an LM locally, the model fits in memory, but the KV cache grows during inference. So the local RAM fills up and the process crashes. With MemCloud, that overflow memory is streamed to a peer machine instead. So basically, what does this mean is where if since this KV cache, it increases gradually, like the size of it increases gradually. So this overflow memory will be streamed to a peer machine connected via MemCloud, and the application keeps running. So in this, no code changes, no disk IO, and nothing, and our application would work. So the goal of MemCloud is not to replace databases or any sort of storages. its purpose is very focused. Like we can, better hardware utilization. Like we can use our hardware very efficiently and utilize it to the extreme, and running larger workloads on smaller machines and enabling local first AI systems. So this is the whole idea of MemCloud. And the bigger picture that will be there in the future is like as AI moves from centralized cloud setups to local and edge machines. Because as you are aware, na, these cloud setups are very huge and getting huge day by day. And there will be a time in future where these cloud setups will reach their limit, and then people will shift to their local setups. So in that case, people will be needing something that can bind their multiple device RAM together, or multiple CPU maybe in the future together, so that it can work as a giant machine alone. So instead of vertically scaling your single machine, you can combine them together and work and and use them as a unit. So this is the whole idea. So MemCloud is my attempt to rethink memory as a shared resource, not something locked inside a single machine. Okay, so this is about MemCloud. Now I'll tell you how what are the different kind of commands that are provided by MemCloud, and how we can install it on our system and everything. So this is the website, like I have put it on Versal.app, for instance. You can just go through and check how these are, how MemCloud, what are different commands of MemCloud, how it enables us to connect to our peers. It has a proper documentation here. Everything is written here. You can just check out. I'll go you a very brief introduction of these commands, and give so that you can have a gist of what actually MemCloud is. So basically, MemCloud provides you this MemCLI tool through which you can, connect to your peer. You can set some value over some peer. You can get the values and anything you can do with the help of this MemCLI tool, right? And the repository is this MemCloud. So it is an open source repository. You can just go, you can just clone it or whatever you want, and you can start contributing it. I have put everything here so that you can have a gist of how things are working in MemCloud. So without wasting any further time, let's move. So when you go over this documentation, so you have this macOS Linux link to download it. So I have two devices here with me. This is my Mac device, and another is a laptop that is a Ubuntu device. So I'll install this command on both the devices. So just copy it and go to your terminal, and you need to paste it. So once pasted it, it will identify which type of device it is, and it will install the MemCloud accordingly. So let me put my password. So this is installed. As you can see, everything is installed here, and the same command I am running on to my Ubuntu machine as well. One, okay. So I have put this command on my like installation command on my Ubuntu, and it is installed there also. Now, since this is installed now, so let's check how what is the status of this. So memcli node status is the command which will tell you whether memcloud is up or not. So it is saying memcloud is not running. So we just need to type memcloud node start, and we can provide some name to our device. Mac I am providing, and also the total memory that can be pooled, when someone is connected to your device. So I am putting here it as 4 GB. So using memcloud, the peer device can leverage only 4 GB of RAM. So this is the setting that we are putting here. So we are starting our server, and since you are saying you are seeing here is node started successfully. So the by default port for any MemCloud daemon is 8080. So you can just provide any port using this minus minus ports. But for instance, let's go with uh, default one. Now again typing memcli node status. So you must see it is a running. Now I am providing. Sorry, I am starting it this node onto uh, Ubuntu one also, and yeah, the same command, this memcli node start, I have put it on Ubuntu. Now what I'll do is I will try to connect uh, to Ubuntu device from here. So we'll put memcli node connect, memcli connect and the IP of my Ubuntu system. You can check the IP of your system using ifconfig. So this is the thing. And here, like while connecting, we can offer our storage using this offer storage flag. So what does this do is, like when I am connecting to this system, like Ubuntu system, I can offer 3 GB of my RAM to it. So when if I am pressing enter, so it is saying it is waiting for approval. So if I am going on Ubuntu device and check memcli consent, so it is saying yeah ki Mac device is wanting to connect and it is offering 3 GB of storage. So I have these four options like allow, trust always, deny, and skip. So we can choose any of the thing. If we are denying it, so the connection like it is not allowed to connect, so it is the rejected by peer user. If I am trying to connect again, then it will go again for the approval. Now again I have the four options and I can trust always the device that is trying to connect. So here, as you can see, is the consent is granted, the connection is established, and the secure session. Like whatever the data is exchanged between the devices, it is secured. Like it is encrypted first, then sent, then it will try to check whether the encrypted content is correct or not. If it is not, then it will reject the handshake, and everything is in a secured manner. So in this way, we have connected to our peer. Now let's check what peers are connected to us. So this is a Ubuntu device at this address, and it is allowed 3 GB of storage onto this machine. So basically, if Ubuntu want to write something on our device, so it can write 3 GB of it can use 3 GB of RAM from our Mac device, and also the capacity offered from the capacity offer is like 4 GB. Like this Mac can use 4 GB of Ubuntu RAM. So this is the whole idea, right? Now let's move to the documentation. So there are further commands like this peer list, like as this is the peers command now, so we can type in memcli peer. So this is the same thing. So it is a alias. Now we can update the storage also. Like if it is allowed 3 GB, then we can make it 4 GB, 2 GB based on our convenience. We can allow it. Now as we are connecting to our peer, we can also disconnect it from it. So this is the command like memcli peer disconnect, and we can disconnect from there. Okay. So now let me try to run this memcli store hello world, and here I'll just press enter. So whenever we are not passing any peer name, then it will by default store this hello world onto the same device on which this command is run. So basically this hello world will be stored onto the Mac itself. So if I am sorry memcli load, if I am trying to memcli load this ID of the block that is stored, so it will just return us hello world because it is, and the time you can see now this is 72 microsecond, which is very less because it is loaded from the same device RAM. Now what if I want to store let's say hello AI, and the peer device I can type here is Ubuntu. So it has basically stored this hello AI onto a peer device, so which is saying remote true and mode is pinned. So these are some sort of modes that I have put in MemCloud, like pinned mode, cached mode. So these are the things. Now the time difference you can see here is like when I was storing hello world on the same device RAM, it took 152 microseconds. While I tried to store this hello AI on Ubuntu peer, then it took me 366 microseconds. So this is the sort of double latency that is coming, but that is obvious because we are trying to use peer RAM. So that transferring and everything is taking a bit time, but that is obvious. Okay. Now if I am trying to load this memory, this ID, so it will try to get this hello AI, and the time difference is like this 72 microsecond and this is 93 microsecond millisecond. So this is the latency shift that you are seeing, and that is because of it has loaded this block from the peer device. So like I have this command memcli logs minus f, which says like this one or this block has been fetched from peer. And same thing is like when we tried to fetch this now this one, so it was being fetched from the same device. So there was nothing printed here from here because memcli didn't fetch anything. Like it just get the thing from the local machine RAM only. So the likewise we have the like store and load. In the same way we have this getter and setter. So as we set our keys value in Redis now, so in the similar way in memcli also we can set memcli set a b. So in this way it has been written or set at the local machine RAM only. So if I am trying to get a, so it will just print p, and the time also you can check. Now what if I want to store it on peer? So set c d minus minus peer ubuntu and then enter. Now the time difference you can check 64 milliseconds and microseconds. So this is a difference because it tried to write this key onto my peer. Now I can just get C. So first it will check if this C is present on this local machine. If it is not, then it will just go to my peer machine to check this key. Now what if I just stop the node that is running my Ubuntu machine, like the memcli node. Let me try show you that. So memcli node stop. I am running. So if that node is stop. Now what if I am running this memcli get C, because this C is on that Ubuntu machine only, and this Mac has no clue about this C key. So what if I am trying to run it here? Let's see. So if it is trying to get C, then it is not finding the no this key because that node Ubuntu node is stopped. Now again I am starting it, and again we need to connect to it. And since last time we allowed always trust, so we it was not waiting for the consent now, and it directly connected to it, and the handshake was successful. Now, whenever some node is stopped, then all the memory present in their RAM is get like gets cleaned. So if I am trying to get C, so it will not again find it because the RAM gets disposed of, right? So this is another thing. In the same way, you can set a stringified JSON here. You can just get it, all these things. There are two sort of modes here, the pinned mode and cache mode. Whenever we are setting some key, this key and value, then we can just set the minus minus mode. So this uh, pinned is a by default mode that is present in MemCloud. So when pinned mode is enabled now, so this guarantees to stay in memory until explicitly freed or node restart. And the cache is this is evictable if memory pressure hits, because if the memory usage is very high, so it will try to evict based on the LRU policy, like the least recently used policy. It will use to clear out the data such that the memory pressure can be handled. So these are two sort of modes here. Now they are like as you can see, if you are having a huge log file and you want to stream that file to peer RAM, so you can just use this. You can put minus minus peer and the peer name so that this goes to the peer device. So these are sort of commands that are being provided by MemCloud to you. Now the thing is, if you want like this is the in a development project, like I am working on it daily, like some feedbacks I am being receiving from my colleagues, some of the friends or some of the community members. So based on the feedback I am working on the things, like there is a lot of work that need to be done into this. Optimization need to be done. So in case you want to contribute to the project, like you can just clone the repository and then follow these steps to run it on your local. Okay. And then this thing now, when we are running this memcli node start, so it is basically a daemon that we are running. So it is called cloud daemon. So whatever device you want to connect to, this daemon must be running so that they can connect it. Now, these all the are the steps you can follow in order to contribute to the platform. You can follow this contributing.md file. It will tell you what kind of commits you want, what kind of commit names you have to follow in order to you know contribute to the system. And this website is also open source, so in case you are thinking that this website can be made more you know uh, good in terms of UX and UI, the contributions are always welcome. And the feedbacks, I am really appreciating anyone who is giving me the feedback to make this platform a better one, and better adaptation is there in the future. So I am waiting for someone who can contribute to it, who can give me feedback and everything. So all these things I have worked alone currently, but based on the feedbacks I have been received lately, so I've made many things. So after this video, I'll be providing a video where I'll provide you a demo of how we can run LLM models locally and how MemCloud is helping us into that. So yeah, that is about today's video, introduction video about MemCloud. This is the architecture diagram, and you can go through it, how the things are getting exchanged, how they are communicating, what kind of protocols I have used, everything I have made here in order to make the developers who might be working on to the contribution part a better understanding. And so that is about today's video. Thank you.